Dear students, here is a question for you. If the pth term of an AP is Q and qth term is P, prove that P plus qth term is 0. For many students, this type of question arises some problems because they are much familiar with numbers in arithmetic progression. Here in this particular question, instead of numbers, we have certain variables P and Q. This may confuse them. There is no need to confuse in this question because it is very similar to the way in which you deal with arithmetic progression consisting of numbers. You can simply approach the question as you approach arithmetic progression with numbers. Let's see how to answer this question. To answer this question, we use this formula. It is given that pth term, AP, is A plus P minus 1 into D. It is Q. AP, the pth term of this AP is A plus P minus 1 into D is Q. That is A plus PD minus D is equal to Q. It is also given the qth term AQ is equal to A plus Q minus 1 into D is equal to P. That is A plus QD minus D. D into minus 1 minus D is equal to P. We have two equations, equation 1 and equation 2. Equation 2 minus equation 1, A minus A 0, QD minus PD. QD minus PD minus D minus minus D is minus D plus D is equal to 0 is equal to P minus Q. That's equal to taking the common term out of the two terms, D into Q minus P is equal to P minus Q. D is equal to P minus Q by Q minus P is equal to minus 1. Please note, A minus B by B minus A is equal to minus 1. Now we have the common difference is minus 1. Now we have the common difference D as minus 1 and we need to apply the value in any one of the equations that we obtained earlier. I consider this equation AP is equal to A plus P minus 1 into D is equal to A plus P minus 1 into minus 1 is equal to Q. That is A minus 1 into P minus P minus 1 into minus 1 plus 1 is equal to Q, and A is equal to, this minus P becomes plus B, P plus Q plus 1 becomes minus 1 on the other side of the equation. This is A. Now we need to find P plus Q the term. That means A P plus Q is equal to A plus P plus Q minus 1 into D is equal to, we know what A is, P plus Q minus 1 plus p plus q minus 1 into minus 1, d is minus 1, is equal to p plus q minus 1, minus 1 into p, minus 1 into q, minus 1 into minus 1 plus 1 is equal to p plus minus p is equal to 0, q minus q is equal to 0, minus 1 plus 1 is equal to 0. We have 0 as p plus qth term. Here is another question for you. How many three-digit multiples of 13 are there? This is the question. We need to find the three-digit multiples of 13. The first three-digit number is 100 and the last three-digit number is 999. Now divide 100 by 13 because we need to find the multiples of 13. 7 times 91 and the remainder is 9. Now you subtract 9 from 13. 13 minus 9 you get 4. You add this answer to 100. 4. Now we have 104 is the first multiple of 13, which is a three-digit number. Because it is the multiple of 13, you need to add 13. 104, then 117, then 130, and so on. Now we need to find the last number also. Now divide 999 by 13. 7 times 91. We have 8, 89. 6 times 78. The remainder is 11. Now subtract this remainder from this number 11. Now we have 988 as the last number, last three-digit number, which is a multiple of 13. Now you can easily find out the number of multiples of 13 by using this formula. N is equal to number of multiples of 13. N is equal to an minus a by d plus 1 is equal to, this formula is actually derived from this one. N is equal to a plus n minus 1 into d. It is from this formula, this shortcut formula is obtained. N is 988 minus 104 divided by 13 plus 1. 13 is the common difference because it is the multiple of 13. It's equal to 884 by 13 plus 1 is equal to 68. When you divide 884 by 13, you get 68 plus 1 equals 69. There are 69 terms or 69 multiples of 13 which are three-digit. Now we have two questions for you. The first one is very similar to the question we have worked out with pth term and qth term instead of mth and nth in the question. The second one is also similar to the second question we have done. In that question, it was the multiple of 13. This question is multiple of 7. Do yourself all the best.